Hello everyone. Today we are here to present our project, that is analysis and prediction of bike availability using bike share datasets. So these are the points that we will be covering today in our presentation. To start with, basically Bay Area Bike Share is a public bicycle sharing system wherein you can just rent a bike to go from one place to another. We have basically utilized the datasets provided by this bike share website, which included the trip status and weather data, and we just studied the different patterns, the different parameters that are affecting the bike availability. And our main aim of this project is to come up with a model that would help us to predict the availability of the bike considering the inputs that are given by the user. And our basic approach was to study the different attributes that are affecting the availability of the bike. So this is a website that provided us the public data for 2 years, that is 2014 and 15, and the different data were present in the form of individual trip data, status data, and the weather data. The size of the data was approximately 1 GB, consisting of 36 million records, and the format of the data was in the CSV file. So this is the data flow diagram of the data processing we did in our project. So basically we initially merged the trip data for 2014-15, similarly for status and weather. And then for the next step, we converted the data types for some columns, like for start date we converted it from factor to POSIX, end terminal from integer to factor, and all other different attributes from integer to factor. And similarly we did it for the status data and weather data. The reason for converting to factor was because we wanted the data to be in categorical data type so that it would be easy for our model when we are doing the prediction of bikes. And then we eventually merged the trip status and the weather data for both the years. Eventually getting one file, we cleaned all the NA value rows and moved the value to no event, and we removed the irrelevant columns that were not at all associated when we were predicting the bike availability. And we also merged all the bike availability per minute data and uh, combined it to give us a bike available per hour columns. And then we plotted different scatter plots to see the relationship between the bike available per hour and all other different parameters. And the methodology we used for data splitting was just randomly dividing the data into training and test sets. The basic approach we followed was randomly dividing into two sets and running our algorithm. So we found out that the training set and the test set ratio of 75-25 gave us the best result. The technologies and tools that we used are the R language. We found it easy to process the data, apply the different algorithms, and visualize the results because it provided different R packages. And we use the R Studio because it is the IDE for R language and it provides a good interface for both writing and saving the R scripts. Now I'll call on Surbhi. She will explain about the different algorithms that we used in our project.
Hello, I am Surbhi. I will be explaining the algorithms which we have used and the graphs which we have got after analysis. We have used three algorithms: multiple regression, random forest, and gradient boosting machine. So, multiple regression tends to give good results in a lot of scenarios. It is simple to interpret since there are fixed number of parameters to fit in the prediction model. That is why we decided to use multiple regression. Second algorithm we used is random forest. These algorithms are collection of multiple trees and tends to give better results than single decision tree. That's the reason we use random forest. Third one is gradient boosting machine, wherein trees are grown sequentially. This algorithm helps avoiding overfitting the data and tends to work well by learning slowly. Hence we decided using this algorithm. This is the screenshot of a GUI wherein we have provided user an option to choose an algorithm and input fields for accepting values like start terminal, event, etc. Once the user clicks on predict, the count of bikes available is predicted according to the algorithm chosen and is displayed. We have also plotted graphs to visualize the impact of parameters on prediction values. Next is I will be talking about some of the graphs that we plotted for choosing the parameters for building the prediction model. In this graph, we wanted to show the variation of start terminal on our response variable, which is bike availability per hour. There are other box plots showing relations between zip code, events, and bike availability per hour. Hence, we can see the variation of these variables on our response variable. In this graph, we have plotted the summary of random forest model built using entry equals to 500. In the plot, we can see the error stabilize at entry equals to 300, and thus we changed entry value to 300 from 500. This is a GBM plot for start terminal where we can see the frequency of start terminal and how it affected the response variable. Finally, in this slide, we have presented comparative analysis of three algorithms used in our project. We can see the RMSE of multiple regression is much lower than GBM and also lower than random forest. We also found that multiple regression takes less time for execution. Now I invite Gaurav to present his part.
Hi, I'm Gaurav, and I'll be talking about our experiences working on this project. So this slide talks about some decisions we took. Now, first one was about calculating aggregated count of the bike availability for each hour. We felt this was necessary because after merging trip status and weather data sets, there were two columns, one indicating trip date and other indicating status record timestamp. Second one was about processing raw files individually. At one point, we were thinking about using AWS or HDFS for processing this huge data set, but that would have meant a steeper learning curve, and so we eventually dropped this idea. So these are the difficulties we faced during the course of this project. As I mentioned earlier, huge data sets would require a lot of RAM for processing. And we had actually used our programming language, and which primarily operates on RAM. So we overcame this problem by processing files individually and then later merging them once the processing is done. Now, applying second one was about the second difficulty was applying random forest on original data, which didn't work initially because RF algorithm does not work well for categorical predictors with more than 54 levels. So we decided to extract data sets related to top 6 star terminals, and we applied RF algorithm on this data. These are the things that turned out well for us. So the RF algorithm, which we ended up applying on subset of data, worked pretty well. And its RMSC was found out to be around 4. Things that didn't work well for us include the C-forest package. This C-forest algorithm tends to work well for data sets which has a lot of categorical variables with different levels. However, this was extremely slow, and even for subset of data, it would take hours to process, and thus we found it infeasible to use. So here are our conclusions. We used 3 prediction algorithms and compared their predictions using RMSE and speed of execution. We found a multiple regression algorithm better in terms of RMSE and speed of execution than RF and GBM, and hence we would recommend multiple regression for bike share data sets. And finally, here are our references. Thank you.
Hello everyone. So this is a demo video for our bike share project. So this is how we launch our project. You just type run example and the name of the folder where we have all the files and press enter. Okay, so here you can input the type of algorithm you need. We have used like 3 algorithms: multiple regression, random forest, and gradient boost machine. So as of now, I'll show you the demo using the multiple regression algorithm. I have used some pre-filled values just to save time. So we have inputted the zip code as 94107, the start terminal being 61, the subscription type being customer, the event is fog, end terminal is 31, and the date we have input is like 2015-11. So I'll just make it 30 for today, and the time is 15:00. And I'll click the predict button. That will show me the bike availability prediction for the inputs I just provided. So this is the output we got, that is the bike availability using the multiple regression. So the prediction is 17 bikes are available as per my inputs. And these are the different plots that we are receiving from this algorithm. The first one being the start terminal versus the bike availability. And the second one is the events versus bike availability. Third one being zip code versus bike availability. And the last one that shows a graph between the subscription type and the bike availability.